continuation of the topic permutation and combination. This is question 18 of the worksheet, which says 9 cards, each of a different color, are to be arranged in a line. How many different arrangements of the 9 cards are possible? So there are 9 cards, 9 different cards, and 9 slots are available. So the answer should be either 9p9 or 9 factorial, or you use the basic counting principle that in the first slot there are 9 options, in the second slot there are 8 options, in the next slot there are 7, all the way till 1. So I'm going to use 9 factorial, which gives 3, 6, 2, 8, 8, 0. 9p9 will give you the same answer. Part 2. How many different arrangements do not have pink card next to the green card? Okay, let me reread that. It says the 9 cards include a pink card and the green card. So how many different arrangements do not have pink card next to the green card? So in this case, what we'll do, we'll find the total arrangements, which we already have 9 factorials. Total arrangements minus, we'll take the arrangements in which pink and green are together. Arrangements, number of arrangements when pink and green card are together. Okay. So how do we deal with 2 particular entities being together? We group them. So this would be pink and green card being together. They have 2 factorial arrangements because they can be pink and green or green and pink. We're going to group it. So now that is counted as 1 card. And apart from these 2 cards, we have 7 more. So 1, 2, 3, 4, 5, 6, 7. So these are a total of 8 slots. So it will have an arrangement of 8 factorial. And then times the grouped part has an arrangement of 2 factorial. So when pink and green card are together, it's 8 factorial times 2 factorial, and total arrangements were 9 factorial. So 9 factorial minus 8 factorial times 2 factorial, which gives 80640. Sorry, no. That's just 8 factorial minus 2 factorial. So this gives 282240. That's the answer. Okay, part 3. How many? Consider all possible choices of 3 cards from 9 cards, with 3 cards being arranged in a line. So now out of the 9 cards, you have to choose 3 cards. How many different, it still says arrangement. So it's still a question on permutation. How many different arrangements in total of 3 cards are possible? Okay, so now from the 9 cards, you have to arrange 3. So that's going to be 3 slots available, but the cards are total 9. So that's going to be 9p3, which is 504. How many of the 3 cards in part 3 contain the pink card? Okay, so now pink card needs to be included. So we're going to arrange the pink card first. Pink card itself is a single card, but it has 3 possible positions it can go to. Pink can be here, or in another case, Okay, pink can take the first slot, or in another arrangement, pink can take the second slot, or in another arrangement, pink can take third spot. So we're going to say 3 spots for one pink card. So 3p1. Okay. Times. Now, if we take away one pink card, we have 8 cards left, and 1 spot has been taken by the pink card. So 2 spots are available for the remaining 8 cards. So 2 spots available for 8 cards means 8p2. So 8p2. So 3p1 times 8p2. That is 168. Okay. Next is, how many of the arrangements of 3 cards in part 3 do not have pink card next to the green card? How many of the arrangements of the 3 card in part 3 do not have pink card next to the green card? So I'm going to do total arrangements minus when pink and green are together. So total was this 9p3 or 504 minus, let's group pink and green together. So pink and green, that's going to be 2 factorial arrangements because it can be pink green or green pink. And then we consider it as a single card. And then there were the total 3 cards have to be selected. So I'm going to write dash next to it because that's a total of 3 cards. 2 इस group में हो गए और एक अलग से हो गया. So that's 2 factorial again. So this should be 2 factorial times 2 factorial. Also, another thing that there are 7 cards that can fit in this place that are contenders for this 1 spot. So इसमें times 7p1 भी कर. So times 7p1. So 504 minus 2 factorial times 2 factorial times 7p1, which gives 476. This is 476 after subtraction. That is question number 18. Okay, now let's start question 19. Three identical cans of cola, 2 identical cans of green tea, and 2 identical cans of orange juice are arranged in a row. So 2 colas, 2 green tea, and orange juice. Okay, no, there were 3 colas. So 3 colas, 2 green teas, and 2 orange juice are arranged in a row. Calculate the number of arrangements if the first and the last cans in the row are the same type of drink. Okay, so 7 of these beverages have to be arranged in a row. 1, 2, 3, 4, 5, 6, 7. However, there's a condition that the first and the last has to be the same. So we can say this is cola, then this has to be cola. Or we can say the first one, 1, 2, 3, 4, 5, 6, 7. First one is green tea, then this one has to be green tea as well. Or first one is orange juice. This has to be orange juice as well. Okay. So first can and the last can in the row are the same type. So this has to be a cola. So there are three contenders for the cola. So I'm going to write 3 here. And then there would be 2 contending cola cans here. So times 2. And in between, take away 2 from 3, 4, 5, 7. So that's 5. So in between we have 5 cans. So that's going to be 5 factorial. So when cola is at the start and cola is at the end, it's going to be 3 times 5 factorial times 2 arrangements. However, there's a lot of repetition here. There are 3 identical cola cans, so 3 repetitions, 3 factorial, 2 identical green teas, so 2 factorial, and 2 identical orange juice, so divide by 2 factorial. So you have to divide the arrangements with repetition, if any. So there is repetition in the question. So we'll get an answer from this, which would be, I haven't written it separately. Never mind. Okay, so this would give us a result. Then there's green tea at the front. So there are 2 contenders from green tea, and then there's a green tea at the end. So there is now 1 contenders for green tea. So 2 times 1, and in between there's 5 factorial. So 2 times 5 factorial times 1 divided with the repetition 3 factorial times 2 factorial times 2 factorial. And then when there's orange juice at the start, there are 2 contenders for that. And similarly, 1 contenders for the last pot of orange juice. And in between, there's 5 factorial. Divided by 3 factorial times 2 factorial times 2 factorial. You find these individual results and then you add them. So this plus this plus this. Which gives 50 in the end. It's supposed to be 50. Whatever is the answer, you add the next answer, then you add the next answer. It gives 50. Okay, part 2. 3 cans of cola are all next to each other. So let's group them. It's going to be cola, another cola, another cola. So that's 3 factorial. Okay. Group it as a single can with arrangements 3 factorial. So 3 cans are next to each other. So these are those 3 cans grouped together, 3 factorial arrangements. And the 2 cans of green teas are not next to each other. अब not next to each other में क्या कहते हैं कि this is one group of cans and then we have an orange juice and an orange juice. So let's place these together. Colas are together and then we have orange juice and orange juice. Now the green tea cannot be together. So no 2 green teas can be together. So first we have 3 factorial from here. Okay. Then green tea can be placed here. Another green tea can be placed here. Another green tea will be placed here. Another green tea will be placed here. So now the 2 green teas are not next to each other. And that's going to be 1, 2, 3, 4. 4 P2. 4 available spots for 2 green teas. And then I forgot to write the arrangements for the group and 2 more places. So that's 3 factorial. So this black part, all these three values give 3 factorial. All these three arrangements give 3 factorial. So times 3 factorial. And in the denominator, you have to cater for the repetition. So there are 3 repetitive cans, 2 repetitive juices, and another 2 repetitive, uh, what was that? Green tea. So this gives 18. Question 20. Twelve coins are tossed and placed in a line. Each coin can show either a head or a tail. Find the number of different arrangements of head and tails which can be obtained. Okay. We're going to use basic counting principle here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many arrangements can these be if you're tossing a coin 12 times? So in the first spot, how many outcomes are possible? It's either head or tail. So the first event can happen 2 times. The second event can again happen, it's 2 times. You flip a coin again, it's either head or tail. Then times 2, times 2, times 2, times 2, all the way till the end. That means the answer for part 1 is 2 power 12. What is 2 power 12? 4096. So we've used basic counting principle. If event A can happen in m ways, if and event B can happen in n ways, then A followed by B can happen in m times n ways. So each of these events can happen in 2 ways, either it's head or tail. So it's 2, 2, 2, 2, 2 all the way till the 12th entry. So it's going to be 2 power 12. Find the number of different arrangements which contains 7 heads and 5 tails. Okay. So now 7 of the outcomes have to be head and 5 have to be tail. So out of 12, 7 have to be head, and then take away 7 from 12, that's going to be 5. So out of the remaining 5, all 5 need to be tail. And divided by repetitions, what are the repetitions? 7 heads, so 7 factorial or 7p7 times 5 tails, 5 factorial or 5p5. This gives 790. Okay, कोई questions हैं तो please बताओ. If not, then we move on to question 21. In how many ways can all 9 letters of the word telephone be arranged in line if the letters P and L must be at the end? Okay, P and L must be at the end. So there's just one P and one L. So P can be here and L can be here, or L can be here and P can be here. So there's just one spot here and one contender here, or one contender here and one contender here. So, and then in between there are 7 slots. Okay, so we've placed P and L at the extreme ends, and now in between there have to be 7 letters, so 7 factorial here, and 7 factorial here. So it's going to be 1 times 7 times 1 and 1 times 7 factorial times 1. And apart from P and L, any repetition? Yeah, E is occurring thrice. Anything else? I guess not. Okay, so there's just 3 E's. So it's going to be 7 factorial times 2 divided by 3 factorial. Instead of doing 7 factorial times upon 3 factorial and 7 factorial upon 3 factorial and add them, I'm doing 7 factorial times 2 upon 3 factorial, which gives 16/8. That was part 1. Okay, part 2 is there are no E's. Okay, but first we have to read the remaining part of the question. How many different selections of 4 letters can be made from the 9 letters of the word telephone if there are no E's? Okay, so remove E's. So that means you either have T, L, P, H, O, N. And out of these, 4 letters have to be selected. How many different selections of the 4 letters can be made from the 9 letters telephone if are no E's? So selection is combination. So that this should be 6C3. 6 options, but sorry, 6C4, 4 spots. So that's 15. This gives 15. Okay, next is there is exactly one E. Okay, so E can be anywhere since it's selection, so that's combination. So the sequence does not matter. So one of the spot has been taken by E, but the other 3 slots are available for the remaining 6 letters. So 6C3 times 1 or just 6C3. Which is 20. Okay, part 4. There are no restrictions. So you have to choose 4 letters from the 9 letters of the word telephone, but there are no restrictions. So 1, 2, 3, 4. Okay. There is no restriction, but there is repetition. So you have to keep a check on the repetition. So we can say that in the first case, there's one E. So that we've already done before. This gives 20 combinations. Then what if there are 2 E's? Then that would be there are 1, 2, 3, 4, 5, 6, 6 letter left for 2 spots. So that's going to be 6 times, 6C2, which is, God knows what, 6C2 is 15. Then we can consider the case where all 3 E's are there. And then 1 spot is left for the remaining 6 letters, 6C1, which is just 6. and then the case where no E is selected. So take away 4 E's, and then we have 6 letters left, 6C4, which gives 15. That's a total of 56. Add them together, we get 56. So हमने selections किए, arrangements नहीं किए, so we use C. So selections में जब भी repetitions होती हैं, आपने सारे cases को अलग अलग करके देखना है और उनके total combinations को add करना है. So we saw a case where there was a single E, saw a case where there were 2 E's or 3 E's, and then no E's. So we added all those combinations. So जी अगला question. 11 letters of the word remembrance are arranged in a line. Find the number of different arrangements if there are no restrictions. So that's going to be 11 factorial in the numerator, or 11p11, and then write the number of repetitions in the denominator. So r is there twice, and e is there thrice, m is there twice, I think that's it. And apart from these letters, we have, let me fix this E, B, R तो हो गया, A भी हो गया, N, C. So 4 more letters. Okay. So 11 factorial upon number of repetitions. So we have 2 E's, 2 R's, sorry, 3 E's, 2 R's, and 2 M's. So it's going to be 2 factorial times 3 factorial times 2 factorial. So what does this give us? That's a big number. 1, 6, 6, 3, 2, 0, 0. Part 2. Find the number of different arrangements which start and finish with the letter M. Okay, so there are 11 letters. First has to be M. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 हो गए. So M is here. Okay, now it's correct. So the first one has to be an M. The second one has to be an M. So now take away the M. So we have 9 letters in between. So that's going to be 9 factorial, but divided with the number of repetitions. So M तो इधर हम include ही नहीं कर रहे middle में. So it's going to be 9 factorial upon what else is repeating. There's E thrice and there's R twice. So 3 upon 3 factorial times 2 factorial, which gives 30240. Part 3. Oh, Part 3, find the number of different arrangements which do not have all four vowels next to each other. So I'm going to say total minus vowels are next to each other. Okay. So how many total arrangements were there? Find the number of different arrangements which do not have all four vowels next to each other. Okay. So we already have total arrangements from part 1. That's 1, 6, 6, 3, 2, 0, minus vowels are together. Let's pack the vowels together in a group. So it's going to be E, 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 and then this A. This one was supposed to be A. Okay, so there's A, another vowel. These are all the vowels, so that's going to be 4 factorial. Consider this a group. So 4 factorial. So take away 4 from 11, that's going to be 7. So 1, 2, 3, 4, 5, 6, 7. And in total, it's going to be 7 plus 1, 8 factorial. So it's going to be 8 factorial times 4 factorial when vowels are together. So when you subtract them, you get all the arrangements where the vowels are not together. Oops, I forgot to divide with the repetitions. So again, there were repetitions, 3 E's, 3 factorials, 2 R's, 2 factorial times 2 M's, so 2 factorial. Okay, that gives 1622,880. Okay, part 4. Part 4 is find the number of different selections which contains no M's, no R's, and at least 2 E's. Okay, so 4 letters from the word remembrance are chosen. So now this becomes a question on combination. So you have to consider the case that there's no M, no R, but at least 2 E's. So we're going to consider a case where there are 2 E's. Then we're going to consider a case where there are 3 E's. So when we take away E, R, and M, then we have 4 letters left. So we have 4 contenders for these 2 spots, 4C2. Then we have 4 contenders for this 1 spot. So that gives, what is 4C2? That's 6. And 4C1 is just 4. So 6 plus 4, which is equals to 10. मेरे ख्याल में इधर एंड करते हैं और इंशाल्लाह कल से we're going to start probability distribution. Okay, take care. Allah Hafiz.